Hi guys, Shouvik here. Welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have sort colors. So on this problem statement, they have given, so it is tagged as a medium questions altogether, but it is obviously a medium problems, not an hard difficulty, but the difficulty is going to become like based on the constraints like interviewer going to be enforced to your submissions. Then it can becomes on hard difficulty, like if there is a very popular algorithms is going to be fit for this particular problems that you don't aware of, then I personally feel like coming up the most optimal solutions is kind of like almost impossible to in an interview. Yeah, so we first go to understand the problem statement, then we will discuss the solutions accordingly. Yeah, so they have given an array nums with n objects colored red, white and blue. Sort them in place so that objects of same colors are adjacent with colors in the order red, white and blue. We will use the integers 0, 1 and 2 represents the color red, white and blue respectively. You must solve this problem without using any library sort functions. So they basically given us colored array, which are three colored array, which are red, white and blue. So red is denoted by 0, white is denoted by 1 and blue is denoted by 2, and we have to sort. So let's forget about the color. So color is just a mapping of 0, 1 and 2. So we have to sort the array which holding only three kinds of elements, that is of 0, 1 and 2. So yes guys, the problem is as simple as that, and the follow-up is, could you come up with one pass algorithms using only constant extra space? So this follow-up is actually making these problems to a different level. So if you are able to solve these problems with this constant, then you are like on very good step to solve like crack any interview. But yeah, like I personally feels like coming with that particular algorithms with an interview is kind of like quite challenging, because there is a very sharp intuitions we need to incorporate to identify that. Yeah, so I will first discuss couple of root and better ones. So let's go into that first, then I will come on the most optimal solutions. Yeah, so what they have given to us, they have given an array. They have given an array containing, what happens? So they have given an array containing of 0, 1, 2, 0, 0, 1, something like this, and we have to sort the array. We have to sort the array so that like zeros, it becomes 0, 0, then 1, 1, then 2, something like this, right? So we have to sort the array. So they have strictly asked us to not using any library function. So we will not do. So what we can do, we do a single pass and store how many. We will start with a frequency map or a default dictionary to basically store how many times 0 has occurred. Let's suppose 0 has occurred 2 times. Then 1 has occurred how many times? 1 has occurred 2 times, and 2 has occurred how many times? 1 times. And then, so that is the first loops, that is a big of n we are doing. Then another loop, we will do a second big of n, and we are basically populating. On first 2 indexes, we are directly updating whatever the value they have, we are directly updating to 0. Next 2 indexes, whatever the value it has, we are directly updating to 1. Next 1 index, what if the value they have it, we are directly updating to 2. Then our nums becomes sorted. So that is kind of a big of 2n kind of solutions, because we are using two pass to solve the problems, and on space complexity also we are not basically we are basically creating a hash map kind of data structure which can take big of n. So which is not an big of n, which we all know this is a big of 3 only, because it holds only 3 key. So maybe interviewer are going to satisfied with this, or they will ask to remove the extra space. So remove the extra space to make it big of 1. So in that case also it is very simple. So rather than taking a frequency map, you can take variables only, first, second, or more specifically I have to say, you can take like 0 count, 1 count, and then 2 count. You can take 3 variables only, and rather than storing whatever we are doing there, we are storing 0 count as 2, 1 count as 2, and 2 count as 1, right? And then we can do the exact same thing. So on that case, space complexity is boiled down to exact big of it. Space complexity is going to boil down to exact big of it, right? Very straightforward. Now actually comes to the most optimal solution. So this brute also, you can say like we can use bubble sort in place to sort it. But on bubble sort, the time complexity is going to be big of n square. And space complexity, tell me guys, big of 1. So you can tell these things, like not go to like very like low level implementations to write the pseudo code and writing the code. No, just tell the interview explicitly that there are solutions of bubble sort, merge sort, this kind of merge sort can solve it in log n. But yeah, like, and post that is the better solutions, I have to say, with big of 2n and big of 1. Now comes on the most optimal solutions. Now these most optimal solutions is actually making these problems toward difficult, like difficulty levels, on different difficulty levels, I have to say, obviously, because then that is not a like medium problems at all. So the most optimal solutions is lying on a Dutch national flag algorithms. Dutch national flag algorithms. So if you know, then like you can solve these problems like this on interview. If you don't know, then most of the cases it's almost impossible to come with the most optimal solution. It's almost impossible. So, but yeah, like if you solve like very good amounts of problems and your intuitions like on different levels of, then maybe people can come with the most optimal Dutch and national flag algorithm. But I personally suggest like get a high levels understanding of the intuitions, how that Dutch national flag algorithms is actually working is obviously a prerequisite to solve within your interview this problem. Yeah, so I will give the how Dutch national flag algorithms is working. So there are a couple of steps. There are 4 steps actually. So we know our array is only holding values of 0, 1 and 2. All the values within the range of 0, 1 and 2. So what actually comes to our brain first? So Dutch national flag algorithms is giving us a like few constant, 4 constant majorly. So what they are stating, you have 3 pointers. Low, mid, left, mid and right. We have 3 pointers. So now Dutch is basically stating us your array with 0 to L minus 1, all should holds value of 0. That is the first rule. Second rule is going to be state your left to mid minus 1, all should holds value of 1. Please take very careful notes of these points. 1, 2. Now third points. Your mid to right, I have to say right minus 1. Your mid to right minus 1, all should holds any value. They are not sorted even. Any value or non-sorted values. Or your fourth point is your right to n minus 1, all are holding values of 2. So these are the 4 rules. So please write these rules on your notebooks. If you are like taking notes of everything, then please take a notes. This actually the core or heart of Dutch national flag algorithms. If we are follow these algorithms on every steps, then we are definitely able to solve these problems with Dutch national flags most optimal solutions. So our target is 0 to L minus 1 is always 0. L to mid minus 1, all are 1. And our mid to right minus 1, that actually the unsorted segments. Where we actually have to play our games. And we know our right segment, that is of right to n minus 1, that are all holding 2. So now if I am giving you an array, so what we actually have to think of, point number 3. So that is of our mid to our right minus 1, right? So these portions is actually the point of problems. These portions is actually the point of problems. So I can write it in little bit different. I can write it r plus 1, so that like it can set on a like entire range. Like explanations is quite going to be like on easier path, because I am going to state like our 0 to L minus 1 all are 0, L to mid minus 1 all are 1s, and our mid to right that is exactly same. There is no change altogether, but like I am just giving you that is the mid to are actually the portions where I actually want to play my games, and there I don't actually want to plus 1 minus 1 I am not going to interest. So mid to r is actually our game, and right plus 1 to n minus 1 is also sorted. So we have a segment of mid to r which is actually holding the unsorted things. So this can hold either 0, either 1 or either 2. So if we can define what we actually have to do, and we know there should be some left minus 1. So this segments is actually held by all zeros. This segments is actually held by all ones. then we have some right, and then we have some right plus 1 to that is of our n minus 1. This portions is the another portions. So these portions I can write mark it as something like this. This portions is holding all twos, all twos. So these are all sorted, 0 1 2. So this portions is sorted, this portion is sorted, and this portions is also sorted. So that is actually the points where we actually have to play our game. So if we can define a rules, what we actually have to do, when we are at this particular boundary, So if we are going to try to define it, so if our nums of mid, so here actually the intuitions guys, if we can define these rules, then we have done. So we know all are in the range of 0 1 and 2. This all the values, this mid 2 are all are holding either 0 1. So if it is 0, what we have to do, tell me. Then if nums of mid is equals to 0, so the elements that we encountered is a 0. So we know here we encountered an element with 0, and our left 0 1 some 0 some 1. So this 0 is ideally have to go to these particular points where the first one started, has started, and that particular ones can go here, then what is going to be happen? So let's suppose they are at 0 0 1 1, and here we have encountered at 0, and if we can do this switch actually, then it becomes 0 0 0 1 1 0 0 1 1, and we can move our mid, because now we have this one boundary is going to be shifted till mid, because we know our segments of 0 to mid minus 1 is all holding ones, and I know I have just put a ones to the mid index, so my L to mid now all are ones, and we should go for mid plus ones, because what we actually did, we actually have some segments of zeros, that is of 0 to L minus 1, and we have a segments of L to mid minus 1, which is actually holding all as 1 0, that is actually holding all as 1, and we have unsorted segments, so that is of mid to right we have. So what we did, we just cut a piece from this particular segments which is actually 0, and we put these things to this one which is actually first started to occur 1, and we have moved this 1 to this. So this particular segments to as it is 0 to L minus 1. This particular segments now extends from L to mid. This particular segment is now holding all ones, and this particular segments, can I say, is going to this particular chunks is just going to add to this particular segment, so that it's going to increase its length, right? So there is a chunk. So this chunks, is going to be added. This chunks is nothing but this chunks. So how we add it? We just add a ones. We just take a 1, and we just make this 1 to that particular points, and we make this 0 to that particular points, and these particular points become 0, and these particular points can add to this chunk. So then this particular chunks is going to take one more 0 chunk, that is the one more 0 chunk that has come by swap, then another chunks that is we have at, that is of 1th chunks, is took one more one, right, one more ones, and from my mid sections by the swap, right, because this actually gives it to a 0, and this actually give it here is an 1. This chunks is going to be added here as an 0, and this actually give as an 1. Actually this one is actually transferred from here to here. I think it is a little bit challenging, but I think I am popular, like very naive way I have able to like explain it. But if you are not able to understand, please go to this actual diagrams once more again and try to do your own pen and paper work. Then you will definitely get a gist. So now this particular 0 segments is sorted. We have a 1s segments. 1s segments has now length is becomes changed, that is of 0 to, tell me, 0 to left minus 1, left to mid now, and my mid is now moved to unsorted segments is moved to mid plus 1 to right, this segments is mid plus 1 to right. So that is the unsorted segment. So what we did actually, one elements from unsorted segments, we are able to put it correctly. So now, what is the case we considered? We have considered the case of 0. Now consider the case of 2. So if nums of mid is 2, so let's suppose now on these elements we have encountered this elements is come as a 2, and we know our right plus 1 to n minus 1, these segments is all holding 2s, right? All holding 2s. So I can say, okay, these all are 2s, no? These all are 2s, no? So I can give you a 2, and I can give you a 2, and you can give me, no. So here actually the challenge is, I can give you a 2 from here. We'll definitely do a swap here. So where we actually making the swaps? We are basically sorry. Let me just correct it out. So we have this unsorted segments. We have this unsorted segments. So it is quite difficult, guys. So that's the reasons I am also like in between going to break actually the what's the rules. So our rules now is, it is on mid plus 1 because we have just transferred once. So that is the mid plus 1 is come as an 2, and we know, so this boundary is my R, and we have a right plus 1. So this is actually holding 2s to my n minus 1, all are holding 2s. So now we have found a 2. So what we can do now, I can make a cut from here. I can make this cut as an out, and I can make this cut is also out, and now I have one small cut here, one is the rth index, and another one is my mid plus 1th index, and I know here is 2, here can be anything, 0 1 to anything. So if I know if it is anything, then you can give it to mid, because that is the unsorted segments, and try to sort the right segments, where we have done for the earlier case. We've tried to sort the left segment by doing a swap. Now we are doing the same as we encountered a 2. And we know our right plus 1s is sorted. All are 2s, right? All are 2s here. So what we do? We have transferred this 2. To there. And this arbitrary 0, 1 or 2, whatever the values we have transferred here. So this particular segments is going to again becomes unsorted. Either becomes 0, 1, 2. We are not bothering because we are not moving on mid pointer. Our mid is still standing at mid plus 1s. Here actually it still becomes the portions of the unsorted portions. It's still on the portions of unsorted segments only. And what we did, we just found one more 2, which can be my right junctions, can be a members of this right junction. So rather than making my right to where initially our unsorted segments is mid to in the boundary of our mid is, tell me guys, in our mid should be always less than equals to my right. Our mid is always less than equals to my right? So that is the conditions that we are following. Our mid, where we are starting our mid to R, that is the segments, right, which are unsorted. Mid to R, this segment size is unsorted. So this mid to R, we have found one R elements, which is 2, which can go to R plus 1th segments, which can go to my these particular segments, which are all 2s, which can go to all 2 segments, So we done the swap, and we keep my mid to here only, keep my mid to wherever it is, and we just cut a segments from here. So that is the segments which actually holding 2, and we have transferred this to all 2s from this particular index to a very last all 2s index. After swapping we have converted. So how we can convert them? Then rather than transferring this 2 to R, what we have done previously, we have just move our left pointer. No, when we are transferring our zeros from that particular index to the left boundary, where from 0 to that boundary all are zeros, we have transferred one zeros to them. And what we did on that particular times, where we have done it, where it's gone, man. So basically on that particular times, tell me what actually is going to be happen. So if my nums of mid, when it was 0, on that case we have transferred one zeros to a 0 to some L minus 1, all are zeros, we have transferred one more zeros to them. So that boundary becomes L plus 1, L plus equals to 1, because that has size to more, that has size to becomes one more, and our mid is should move as it is, because that is we didn't basically put some junky elements. We have just put a 1 from there. So our mid can go on that particular case, because we on mid, you remember we have just put in one element. If you are not able to correlate, please go to that particular segment where we have explained this particular nums of mid equals to 0. Now here we are stating if my nums of mid is equals to 2, then we are putting some junky elements to my mid. It can be 0, 1, 2. We are mid. So our mid we can't reduce. We can't increase my mid. But on earlier case we have have the liability to increase the mid because we are putting correct elements. We are putting 1, which is already sorted because first segment 0, then segments 1, then unsorted, then 2s. So we have just put an 1 to that particular segment. So which are still sorted, 0s, 1s, unsorted, 2s. But here we are putting some junky elements from that particular boundary mid to R. We have cut the last right and we have put that to the mid, and the mid which is holding 2, we have just shift to my right which are sorted. So on that particular case, tell me guys, it should be very intuitive. We have decreased my right to R minus 1 so that we have found one more 2 from this to all my right are sorted, all my right are sorted. Yes guys, so exactly that you have to do, exactly that you have to do. Now what is the next case? If my nums of mid is altogether 1, if my nums of mid is altogether 1, so on that case, do we have to do anything? I don't think so. We can just increase my mid to be mid plus 1, because yeah, we anyhow have to, like, if it is 1, then we are all together are in the good state, right? Because our left segments all are zeros, then there is a segments all are 1s, and that is the unsorted segments. On unsorted segments we have encountered somewhere at 1. So we know all these particulars when we are this particular index, all these either 1s, all are bound to be 1s, and there is some right segments to all of its here, all are 2s. So if we encountered an 1 here, so that means 0 segments to till this we are good. Our 1s segments is there, but now we are considering it's till here because we have encountered an 1. So when we are encountering an 1, what our 1s segments, if you remember, what our 1s segments, one note also start crying. We have done so much things. That is of left to mid. So our mid is actually moved to 1 plus 8. So this boundary is basically expanding. Boundary is basically expanding. How we can expand? We are making mid equals to mid plus 1. That exactly we have done. Yes, that's all about the intuitions building, guys. I know it's quite difficult, quite challenging. So that's the reason for very initial I am stating that coming to the most optimal solutions like the Dutch natural flags algorithms, if you are not already know at least the intuitions how the algo is working, then it's not actually possible to come with an 1 hour interview to come to this particular intuitions building and submissions altogether. Yeah, so now we can quickly discuss the code iterations. The code is going to be very simple. So what I actually just explained, I have done exact same things. So I have take n to be len of nums, our left, right and mid pointer I have set. L should be 0, right pointer should be n minus 1, and our mid should be initially start from 0. And we have know our unsorted segments is mid to right, that is the unsorted segments we know. And if my nums of mid is 0, then what games we have to put? We have just have to do a swap of L and mid. We have done the swap and we moved L also. L moved means our 0 segments is expand. Mid move means our weak segments, our 1s segments become expand. So when mid moves, nice. So that means our 1s segments is expanding. So our 0 segment has expanded, our 1s segment has expanded. So all are tail sorted. So we are very good state. And now if it is 2, on 2 case we are just swapping. And we have making two segments on the very right segments which are holding 2s. There is one more candidate we have found. So we are basically putting our right to one more left, so that particular index to all right, all are now 2s. So 2 segments expand. But 1s segments expand, yeah? No, we can't predict because we have just put in junky elements from our R to our mid. We have put a junky elements. It can be either 0, it can be either 1, it can be either 2. So that we have to process by next iterations. But if it is altogether a 1, then we are very good to move our mid pointer. We are going to expand the 1th boundary. We are expanding the 1th boundary to 1 more. Yes guys, so that's all about the Dutch national flag algorithms. I know it's quite challenging to explaining all together, and on understanding also it's quite difficult, but I have tried my best to explain you, to give you the most actual intuition just that I feel I have put it exactly the same to your plate also. So if you are not able to understand on the very first graphs, I will definitely suggest to go to the 1 or 2 iterations on that particular one note explanations. I will definitely suggest, and you can see like this submissions is like 100% faster than all the submissions over the Leetcode, and it's bound to be because that is like a single pass solutions now we are come up. So tell me guys, the time complexity, I think it's not actually need any explanations altogether. The time complexity is bound to be, we are visiting all the elements either by our mid or we are shrinking our right pointers by shrinking the mid to R. So every elements are bound to visit at max 1 times. So, and we have n elements, so the time complexity is bound to be big of n. That is of single pass on. That is not 2n, not 3n. That is exactly big of n. And our space complexity, we are playing our entire games with only variables. So the space complexity is also bound to be constant. That is of big of 1 exactly for sure. And that is bound to be the most optimal time and space complexity that you can achieve for this particular video. And if you guys are able to understand, I personally feels like understanding these problems is around next level things. And if you guys are able to understand that, then what you guys are waiting for? So please do subscribe to your channel, and please share the videos to your friends circle who are also preparing for top product based company and brushing up their TSS skills. And please turn on the notification so that when we are going to live to our next video, you will get the notification as soon as possible, guys. So that's it, guys. That's it for today. Let's meet tomorrow with another beautiful question. Bye, guys. Bye.